Set up a double integral to find area. In this problem, we have y equals x over 2, and y equals 2. Okay, first step is to graph. So the line y equals x is going to be 1, 2, 3, 1, 2, 3. This line. The line y equals 2 is going to be this line. And the line y equals x over 2. So y equals mx plus b, 1 over 2x plus 0. Y-intercept is 0. Therefore, rise over run, rise over run, rise over run, you have this line, which, if you shade the region, you have this region over here. Okay? Now, we then have to determine, is it better to go up, down, or side, side? In other words, is it better to go dy dx or dx dy? And from looking right here, it's better to go side, side. Therefore, it's better to go dx dy because you could just go down, up. But if you go from dy to x, you're going to have a stopping point right here, and you have to find two integrals. Make sense? Okay. So you know dx will be before dy. Now, in order to find the upper boundary of x, or any boundary of x, you take two equations right here and you solve for x. You see how this line is the line y equals x over 2, and it shapes the it determines how far x can go. This will be the upper boundary of x. So solve y equals x over 2 for x, you get x equals 2y. Therefore, upper boundary will be 2y. Now, the lower boundary, you see this line, how it's y equals x, and it shapes where x stops. So right here. This will be y, so x will be y. Now, moving on to find boundaries for dy. You can see that dy, lower boundary is 0, and upper boundary is 2. Therefore, you now have your completed double integral to find area. So this is the equation of area.